I was joking with a couple of you guys earlier this evening. You know, normally this is a 6-hour speaking engagement. I've agreed to cut it down to 3 to 4 hours. So, you know, we'll be out of here shortly. I am actually going to try and be done with my portion of the festivities in the next 30 to 35 minutes. And as Elton mentioned, what Stalwart asked me to come in and kind of do this afternoon and this evening was talk to you about some of the things that RSA has been seeing in the real world in terms of threats that are out there. I'm going to spend a little time talking about giving you some statistics that might be kind of eye-opening in terms of some of the risks that you and your organization may be facing, whether you know it or not. I also am going to kind of lead that into one of the newer RSA solution sets, something we call Security Analytics. It's actually hidden up here on the title slide, Security Analytics. This is a new offering from RSA from earlier in the year. At least for Tom Lennon, who is our local account manager. Tom, put up your hand. Based here in the area, and we're spending a lot of time talking to customers about that. That is the goal in the next half hour or so. We've got a small group here tonight, so don't hesitate. Put up your hand, shout out any questions you may have, either during or after. I will do my best to try and address everything. This first slide is taken from Verizon. And if you are at all familiar with the security space, I would encourage you highly to take a look at the Verizon Data Breach Investigations Report, the DBIR, the Verizon DBIR, publicly available, something that Verizon comes out with once a year. They have a huge hosting facility that you're probably aware of, a lot of downstream customers, and as such, they have a lot of visibility into what's going on in the real world about the nature of the threats. This is taken from last year's report from the 2012 DBIR. And I like to start with this slide because it has some, to me, eye-opening statistics around breaches. So for instance, the vast majority, if you can't be 100%, it's 99% of the breaches led to compromise within days or less. So a breach in this context is somebody gets into your organization, into your IT infrastructure. They're able to come in with 85% of those breaches leading to data exfiltration, data being stolen or removed from a property in that same time frame. So this is the scary half of the equation, days or less. The scarier half of the equation is what you have on the right, also from Verizon. 85% of those breaches took weeks or longer to actually discover. There are other numbers out there on the market that talk about average times where the bad guys are in your environment before you understand that can run into the hundreds of days. It can be a very long time. So the problem that RSA is seeing and that we're seeing in the real world is whether the bad guys who are behind these breaches are competitors or hacktivists or nation states or any other entity, the fact that they can get in and out in a matter of days, and the good guys might not even realize until weeks or months or in some cases years afterwards that something bad has happened. So there's a disconnect between those two figures. And this is very true. We have actually seen this with a number of our customers today. This slide kind of talks about, again, the good guys and the bad guys. And if you look at the very top, this horizontal line is from the bad guy's perspective. There's a model that I'm not going to talk about tonight called the cyber kill chain. It follows 7 very discrete steps. It's a very standard model that we've seen in the defense industrial base and in the commercial space as well, typically starting with surveillance or reconnaissance. And the bad guys will eventually get in, set up the attack, and start the attack in your environment. Crafty bad guys will try and cover up what they've been working on, try and maintain some sort of persistence, and at some point the cover-up's complete and they're maintaining a foothold. They're inside your environment. Maybe they haven't stolen anything yet. Maybe the goal is they want to start by getting a foothold in your environment and just waiting. From a technical perspective, we see that as typically beaconing. So a malware-infected machine on your network might beacon or signal out on a regular basis to what we call a command and control server or a C2 server. That beaconing might be fairly regular, once every 5 minutes, every 10 minutes. In the real world, we've seen beaconing where malware gets installed to a workstation. You might not see a beacon go out once a month, sometimes once a year. Really indicates that we have adversaries that are very patient. They typically have a well-established attack plan. They're willing to wait for what they want. So in this case, that's what the bad guys are doing. The good guys here on the bottom, us, hopefully everybody in this room, we're already focused on things like security, whether it's physical security or virtual security. We might have tools in place right now that are going to allow us to discover whether it's something like a legacy firewall or a legacy antivirus solution. Potentially, we've got intelligence that's going to allow us to forecast stuff is happening, monitoring and controls that are in place. Hopefully, before the bad guys are gone, we're going to be able to identify that something is happening in my environment and to be able to contain it, hopefully eradicate it, run through the response, and recover to get everything back in place. Now, that's the good guy's perspective. If I kind of overlay those two stories on top of each other, the delta that you see here between the attack beginning and when you as the good guys understand that the attack is underway, we call that concept, that window, dwell time. This is the window in the environment where the attacker is inside your environment and you don't know it. Your job, I'm going to argue, is to try and A, understand that model, because that's the nature of the threat that we have today. There's no vendor out there, by the way, including RSA, that's going to come out and say, we have a series of solutions or products that can collapse that window to zero. Nobody who's authoritative should be coming up in front of you and telling you that. The goal is to understand that you do have bad guys potentially in your environment, and as long as you're familiar with this concept of the window, your goal should be to try and collapse that window to something smaller, if at all possible, using the right set of tools or using the right set of techniques, hopefully with personnel that's had the right training. So, traditionally, when you talk about threats in this space, there's a technology area called SIEM, Security Information and Event Management. It's kind of defined here at the very top. That is very logs focused. So if you're in an IT role today, you've got devices. You've got switches and routers and Windows servers and other network devices that are generating logs. Those logs can give you very useful visibility into what's going on in your environment on a regular basis. However, it's almost always going to be a rear view mirror in terms of understanding what's going on in your environment. Had you talked to me 2 or 3 years ago, I would have talked to you about our own legacy SIEM product, which gives you great visibility, but just across your logs population. The reality is there's a lot more information that's available on your network that you should be capturing, should be normalizing to put into the same bucket to give you comprehensive visibility, and I will talk to you about that in just a second. SIEM really, by default, the second bullet, lacks the context and the surrounding intelligence. It's going to be great about giving you specific logs from a device or a group of devices, but it's going to give you that rear view look and not necessarily a current look as to what's going on in your environment. So the conversations that my sales partner Tom and I are having right now is, let's think about logs. You definitely want to collect logs, but there's more to it that you need to collect, and I'm going to talk to you about that in just a second. The other problem that we're seeing and that we're hearing about from customers today is that the amount of data, whether it's logs only, whether it's potentially capturing packets or network traffic, it really is becoming what we would characterize a big data problem. Now, I'm going to stop right now and tell you, if you have any vendor like RSA or anybody else who comes up in front of you and starts talking about big data, you want to call them on the carpet and make sure you understand that is a buzzword. It's dangerously overused. I will tell you that when Ben Smith from RSA talks about big data, I follow the classical Gartner definition that's here at the top, the 3 V's: volume, velocity, variety. There's a fourth category here called complexity. They couldn't quite squeeze that into a V, but that's the classic Gartner definition. So when I talk about big data, not only am I talking about the 3 V's, I'm talking specifically about Hadoop. Hadoop is an open source big data platform that we use as part of the security analytics platform that I'll talk to you about in a second to perform some really interesting analysis around data that's been captured. The fact that the complex IT environment is not getting any simpler. I haven't talked to anybody who's comfortable with getting their arms around everything that's in their environment today. It's getting more and more complex. There's more products. There's more attack vectors from the perspective of the bad guys. As a result, whether you're in IT or specifically in security, many individuals and many teams are really struggling to keep up. A particular survey that was taken a couple of years ago, 40% of those respondents have said, hey, we're overwhelmed with what we're already collecting. Please don't talk to me about collecting anything else because I'm already tapped out. And about a third of them have said, listen, based on what we've got, we just don't have the time and or the expertise. So we've got a lot of customers who have been kind of focused on the compliance space. They're now starting to think about security operations and taking that information, repurposing it. It's a big challenge. So this big data challenge that we have is important, and there's a reason that I'm spending some time on this topic, because I think it's an essential part of any solution that's out there today. Specifically, the 4 areas that I have up on the screen right now. Big data infrastructure, something that's going to allow me to consume massive volumes, massive varieties of information, both from my log-based population and potentially from my packets-based population, which we haven't talked about yet, giving you comprehensive visibility. Because if there's one thing, logs, if there's another data set, packets, there's actually a third leg to the argument that RSA is making here. If you've got all the information around your logs in your environment, that's great. If you're capturing all the packets, if you're capturing all the network traffic, that's another very important data set that's going to give you good visibility into what's happening. But even if you've done that and you're capturing all that information, how do I know if I see that there's a workstation that's beaconing out or communicating out to some external server, the IP address that it's reaching, how do I know if that's a known good IP address or a bad IP address? There's an important third leg, and that's external threat intelligence, information from outside your organization that RSA can provide you to say, if you see traffic to this domain, stop it. If you see information that's traversing to this set of IP addresses, clamp down on it, because these are known bad players, giving you additional context around the log information, around the packet information that you're already collecting. And then finally, because nobody has infinite budget, nobody has the ability to bring on infinite number of personnel, you want to have something that automates the analysis of that to the best extent possible. So the big data infrastructure, the visibility, the integrated intelligence, the high-powered analytics to try and automate that, these are 4 kind of standard areas that, based on what RSA has seen, based on what RSA has experienced over the last several years, we think are going to be essential for any solution. So, having kind of set the stage there, and we're doing great on time, I'm just checking my watch here, let me talk a little bit about the solution that Tom and I are spending a lot of our time educating prospects on, and that's the security analytics solution that I touched on before. RSA then and now has a legacy SIEM, Security Information and Event Management platform, called Envision. RSA then and now has a legacy deep packet inspection platform called NetWitness. Security Analytics is the successor to both of those legacy platforms. So we've got customers who are currently NetWitness customers that are maybe interested in adding log visibility into their current installations. We have current Envision or SIEM customers that are interested in bringing packet visibility into that as well. This is a platform which combines the legacy SIEM tool, the network security monitoring, that's the deep packet inspection that I've mentioned, as well as the big data component, the Hadoop component. I've got a quick slide towards the end of the presentation where I will skip through some of the architecture just to give you a sense of what that looks like. But this is something, believe it or not, that is new and different. There are a lot of companies out there who do log management and SIEM by itself. There's a smaller set of companies that does deep packet inspection. There aren't too many choices out there that do both of those things. And the real power is having both of those data sets, information collected from your logs, information collected from your packets, inside one view. So if you are that analyst whose job it is to maintain security or track down incidents on your network, being able to see the log data and the packet data in one interface is kind of a big deal. If I haven't beat this horse to death yet, let me just reemphasize once again, from a log management perspective, a lot of customers started in the SIEM space because they had compliance requirements. You might be covered by PCI, or you might be covered by HIPAA, or some other regulatory body that requires you to keep your logs for an extended amount of time. Not just keep the logs, but confirm that the logs are being reviewed, confirm that you're running reports in a very specific format, and those compliance requirements are really designed to help you elevate you and your organization to a certain baseline from a security perspective. Elton, was there a question back there? Bring them on. Sure. Yeah. Sure. So the question for the folks who are watching the video, the question was about the attack that occurred at RSA in March of 2011, and if we use any of the technology that I'm talking about tonight as a means to kind of self-diagnose. Quick answer is absolutely yes. RSA was a customer of NetWitness. In fact, on the day that the RSA breach was publicly announced, that was the same day that we were going to announce that we had acquired NetWitness as a company. So the NetWitness tool that we had in place, that's the Deep Packet Inspection tool, that was a tool that enabled RSA to kind of TiVo replay the attack. We were able to see the password that had come down to secure the information that was stolen from RSA. We were able to watch the lateral movement from one machine to another inside the environment. The NetWitness technology was absolutely essential, and not just essential from a packets perspective. When we acquired the company, we decided that the architecture, the underlying architecture for how that was built, how it could be scaled up, was so effective that we have now based our log collection capabilities on the very same architecture. So I appreciate that question, Elton, because NetWitness, definitely an important part, a great acquisition for us in the last 3 years. So taking those two things together, kind of the network security monitoring, that's the NetWitness piece I just talked about, the legacy SIEM or log management tool, tying those two things together into what we call security analytics. We still expect to have a number of customers for whom compliance is a primary driver. So we still have reports that allow you to work with your auditor to say, yes, we are compliant in this area or that area. But once you introduce the packets into that equation, you get something that is contextually very different, contextually much richer. As you can see at the bottom of the slide, it allows you to see things that you didn't see before and understand data that maybe you had never even considered. Doing correlations against those two data sets to see that, hey, I've got certain activity on this router that maybe I've collected through a log, and then I'm seeing network traffic through the packets that I'm capturing. Being able to put those two things together can give you important insights because, especially in the midst of a particular attack, you don't necessarily have a lot of time to diagnose what's going on. We want to try and help you with that. Okay, for the folks here in the room, this is a tough slide because the projector is a little far back, but this is a representation of the web-based interface. If you are a user of security analytics, you don't have to be somebody who understands Wireshark, which is a packet capture tool, to look at the individual packets. If you've got that expertise, that's great. You don't need it. If you know how to open up a web browser, and specifically, hopefully you can read some of these categories like risk warning, risk suspicious, risk informational, destination domain, etc. This is the secret sauce of the security analytics solution. Because as we are capturing all of the logs across your network, as we are capturing all of the packets across your network, we're not just capturing that data and writing it out locally, we're also at the same time creating what I'll call metadata around all of that information. So inside a log entry, for example, I might see something like a timestamp or a source IP address or an error, an informational code, or other information. We can parse out those individual data points from an individual log entry. And then if you think about packets, it gets even more interesting because there's a huge variety of data sets that you can pull out of packet-based traffic. Where did this session originate? Where is it going? What protocol is being used? What port is being used? Instead of having to look at an IP address, destination IP address here at the bottom, we have the ability to automatically, programmatically create metadata to say, hey, if I see an IP address that's in this range, that IP address is registered in Iceland, or in Russia, or in China. So those three words, Russia, China, Iceland, those are metadata values that you can click on directly from within the interface. Kind of tough to see on this, but the screenshot that I took here, you can see there's plenty of room to scroll down. There's a lot of additional metadata, hundreds potentially of different values that just by collecting the information, whether it's logs and or packets, we're going to make it that much easier for you as an analyst to see immediately, hey, I've got some abnormal executables running on my network. I don't have to know what an abnormal executable looks like. Security Analytics has already diagnosed that on the network. And if I want to look at, in this case, you can see very faintly the number 2 next to that hyperlink. There were only 2 sessions out of all the information that I've captured that exhibited this behavior. So if I click on the 2, it's going to throw away everything else in this view and just show me the packets and or the logs associated with that abnormal executable. So I don't have to be, again, a packet expert to understand all of these risk-suspicious crafted HTTP headers. Very common attack vector for the bad guys is they will artificially build out web-based headers, HTTP headers, that don't necessarily follow the established spec. This screenshot, believe it or not, guys, is from my home network. And when I saw that there was crafted HTTP header traffic on my home network, I got a little nervous, quite frankly. Didn't even know it existed before I had installed the product. So what did I do? Well, the number 10 that you see next to this crafted HTTP header, there were 10 sessions, 10 packet-based sessions that had that. I clicked on the 10. It threw away everything else in this view and only showed me information around those 10 sessions. And in fact, they were all originating from a single IP address. They were on a very regular broadcasting basis, another scary sign. They were originating from the TiVo box that I have downstairs. And the TiVo box is checking out with its command and control server, the mothership that has my television programming information. TiVo, the header that they use in that HTTP packet, isn't quite to spec. I don't have to be a web expert. I don't have to be an HTTP expert. I couldn't take a look and say, yes, this is out of spec. Security Analytics instantly did that just by collecting the packets. So while I talked about this as being the secret sauce, it really is a big deal that we're able to collect that and on a real time create all this metadata, bring it into this point-and-click interface to allow analysts to drill down. We like to talk about not just removing the hay so you can see the needles. We like to say burning the hay just so you can get directly to the needles for whatever the incident is that you might be working. So logs and packets in one interface. Just to kind of emphasize that, in fact, I even think this slide talks about the hay and needles analogy at the top, but I would point your direction here, starting with 100% of the total data. If you are consuming all the network traffic and logs in your environment, that can be overwhelming. It's a very common use case that people might get a tool or a solution in place and they just become overwhelmed by all of the information. So maybe as an analyst, my job is to look for any downloads of executables. So think about how a packet and a session might work. If you are the person who was unfortunate enough to click on that link in your email and an executable gets pulled down from the internet, that's going to be inside the packet traffic. So I don't have to be an expert. Security Analytics sees that executable traversing the net, and I can look to hone in on not only downloads of executables, I can also say, I'm interested if I see a type that does not match the extension. So if I'm a bad guy and I'm trying to insert something onto your network that's an executable, maybe I change the .exe to .jpeg or .txt because I want to hide the fact that it's an executable. Security Analytics is smart enough to see any of that traffic if it's actually an executable in that file, regardless of the file type and the file extension, we'll tag that. Both of these examples are metadata that the tool automatically creates. So if I want to look at all the executables, there's a section in the view that I just showed you. Just show me anything that's an executable, and a second click, show me if I have anything that's in that use case where the type doesn't match the extension. Somebody has purposefully renamed that executable to .txt or .jpeg. That's 2 clicks in the interface that I just showed you. And frankly, if that's 2 clicks, if that's 1 click too many, I can show you how to do it in 1 click. If you have a regular use case where you're concerned about both of these things happening together, where you want to drill down directly to it, we can set it up to do it in 1 click. That's just one example of a use case where literally 2 clicks will take you from terabytes of information down to hundreds, thousands, and then the individual alerts, maybe a few dozen alerts. If this is a problem that you had in your environment in the past, it's a quick and easy way to drill down to find out what's going on inside your environment. Okay, this is the scary architecture slide that I mentioned before, and I'm only going to bring out maybe 2 or 3 discrete points on this slide. The first is, I talked a little bit about our legacy history with the NetWitness platform and how we believe that the architecture was superior, very scalable, could grow to very large amounts of information. These 3 tiers that you see here on the left-hand side, I've got kind of a red hexagon here and a red cylinder and then a green triangle. These are the 3 tiers of the Security Analytics platform. And I talked a little bit about conceptually the nature of gathering up all that information, whether it's logs or packets, and assigning the metadata. Both of those things, collecting the information and creation of the metadata, is done at this leftmost layer. We call this a decoder. So it's the decoder, whether it's a physical box, might be a virtual box. Its job is to capture all the packets and or capture all the logs. Its job is also to create that secret sauce, to apply that secret sauce, to create the metadata around all the information that's been captured. That decoder then hands off that metadata to something we call a concentrator, which is really kind of an index of all the information. Here, the concentrator is indexing all the information that's on the decoder. And then finally, the triangle represents the top level tier, which we call a broker. There will not be a quiz at the end of this presentation. What is a broker? What is a concentrator? Just conceptually understand that this allows you to scale, whether you're a very small customer or a very large customer, to some fairly impressive numbers. Many of the customers that we have that are in the small to medium space may have no need to have 3 separate tiers here. Maybe you want to combine these two together. Or maybe I'd like one box, one physical appliance or one virtual appliance that does all 3 of these levels. This is another big strength of the architecture, because we can supply what we would call an all-in-one box, depending upon how much traffic you're trying to consume. That may be very appropriate for your environment. So don't get too concerned if you see all of these multiple boxes out there in a large, especially in this example, multi-geography environment. You might need something like that, but many of our smaller customers are fine with either a 1 or 2 box approach, whether that's physical or virtual. I talked a little bit about Hadoop when I asked you to challenge me on big data before. The Hadoop architecture lives here in what we call the warehouse. So there are customers today, especially those that are still in those industries where you have to keep your log files for an extended amount of time, where that extended amount of time might be as little as 3 months or 6 months. More commonly, it's a year, might be a couple of years. I definitely have some customers that are required to keep their logs for up to 7 years. So depending upon how big those logs are and how long you need to keep them, it might make sense to use the data warehouse. The data warehouse is another component. The 3 boxes that you see here is not far from reality. Hadoop, as a rule, has redundancy that's built into it. So if one of these 3 boxes that's holding your long-term data disappears, you still have the other 2 boxes and you haven't lost any information. So depending upon your requirements, you may or may not need that big data warehouse. It's optional. Only other thing I'll point out here as I kind of look at the big red dot, the analytics dot, one thing I haven't talked about specifically is a concept about malware analytics. Sounds exciting, I know. Try and contain your excitement. Only 8 minutes to go, so we're in good shape. Malware analytics, thinking about we're already capturing all the packets that are on the network. So I gave you on the last slide the example of maybe an executable that I can see inside the traffic. If I'm already capturing information around the executables, why can't I take some additional steps automatically so that a human doesn't have to be involved to take a look at that executable? Is it malformed in some way? Are there certain behavioral characteristics that I see just by looking at it that would indicate potentially that it's malware? We have a malware analysis component that's optionally available with the Security Analytics platform that will programmatically, automatically do that work for you. So if you are in an industry or an environment where you have been exposed to malware, bad software in the past, that malware analysis component can be huge and important, and obviously it integrates cleanly into the Security Analytics story. I know we've got at least one person who's in the auditing space in the audience tonight. I'll just mention for my final point on this slide, these 3 orange bullets at the far right. RSA and many organizations that acquire other organizations have great marketecture slides talking about how we're going to put this acquisition and this acquisition together and create a new product. We actually have real, living, breathing implementation points between the Security Analytics platform and our governance, risk, and compliance platform. Another acquisition of ours from about 4 years ago, a company called Archer. So for example, if you mentally scroll back to the web-based interface that I showed you, I'm that malware analyst. I need to be able to collapse that complexity down, because if I have 100 different workstations that have potentially been compromised in my environment, wouldn't it be nice if I knew that out of those 100 workstations that are exhibiting problems, these 3 workstations have been classified by the business as Tier 1 assets? and the other 97 workstations are Tier 2 or Tier 3 assets. The asset criticality bubble here is a feed-in from this Archer acquisition. It's a standalone version, which allows you, as a business owner, not even connected necessarily with IT, you may already be capturing information about the assets in your environment. You can classify them, whether you want to call it Tier 1, 2, or 3, or A, B, or C. You classify the asset's criticality here, and then that information, guess what, shows up in the web-based interface I just showed you as another piece of metadata. So just like I explained, you can click on a piece of metadata to just focus in or filter on that. If all I want to do is focus on my Tier 1 assets, this is an ability to pull that information in from another source and bring that directly into the security analytics interface. If you guys really want to know more about the architecture, you know where I will be later tonight. We will also be able to give you a deeper dive if and when you're ready on that topic. Okay, I just heard a 3 beep. That sounded like an alarm for a moment, but I'm relieved we're still here. 3 more slides, guys, and we're done. This is just a quick summary of a potential use case. And it's really designed to talk to you about yesterday's solution, which is the SIEM or the log-focused solution versus security analytics. The 4 steps, data exfiltration. These 4 steps starting with suspicious network traffic that you might see on the network. Maybe you see an authorized user, somebody with correct credentials coming in, logging into Active Directory, but then at step 3, you have a different user from the same source IP address now using a different set of credentials. So maybe Ben's credentials are used to come into the network, and then maybe it's Tom's credentials that are being used from the same IP address in the context of the same session. Those 2 things typically should not be happening together unless there's potentially an attack underway. And the 4th and final step, potentially there is information that's going to be exfiltrated or stolen. This is I won't call it a classic attack path, but it's something that we have seen repeatedly at many of our customers downstream. So, where can something like a security analytics solution here to the far right help you? Well, let me take a step back and talk about a traditional SIEM. Again, the security information and event management, it is logs focused. It's going to help you with these 2 use cases. They're actually marked with a yes right here. We're going to show you user activity across Active Directory and your virtual private network. We'll potentially be able to alert you that different sets of credentials have been used in those 2 environments. But it's not going to show you for any access over a non-standard port. What does that really mean? Well, very common attack path is I want to take some custom protocol or something that's not HTTP or web-based traffic, and I'm going to put it on port 80. Port 80 is the standard web port. And if you're in IT today, in any size organization, that's probably the one port that you do allow for outbound access on, because everybody has a web browser. So what if I put a bad protocol on that known good port? If I'm not paying attention to that, that can be a great way for me to potentially steal information. So because security analytics is port and protocol agnostic, if we see access over a non-standard port, certain types of information that shouldn't be on that port, that's another piece of metadata that's available to you right out of the box. So that's an alert or a suspicious risk that you would see in the environment. We're going to be able to recreate activity of that suspicious activity across your environment. Maybe most importantly, we're going to be able to reconstruct anything that potentially was taken. If we see it leaving your organization in the context of an FTP session, for example, you can recreate that FTP session because you've already captured all the packets. We make it easy for that analyst to do that work as easily and painless as possible. So this is the last slide, guys, and it really brings us back to the first 4 points that I made, talking about the big data infrastructure, comprehensive visibility, high-powered analytics, and the integrated intelligence. And let me just one more time hammer in on the integrated intelligence. There are other tools out there, and there will be other tools out there in the future that will start to talk about the logs plus packet story. But without the integrated intelligence, the external threat intelligence, to give you the additional context around what you've already captured, we think that you're missing out on a lot. The good news is, as you might guess, the security analytics platform gives you all 3 of those data sets. With that, I have exactly 60 seconds left. That's not bad.